A geometric series is a series with a constant ratio between each successive term. So just multiply each term by r. And this infinite geometric series can be written as a sum from n equals 0 to infinity, which gives the exact same sum to infinity on the right hand side. Now using this form, we can write the nth partial sum as follows. And if we multiply both sides by r, we obtain the following expression. And now if we subtract the second equation from the first, we obtain the following expression. And on the right hand side, you can see that all these terms are going to cancel, except a and ar to the n. Now if we factor out a and divide through by 1 minus r, we obtain the following result. Now we can observe that when the ratio r is less than 1, then this term here approaches 0 when n approaches infinity, and therefore the series converges, and the sum of the series is a on 1 minus r. Now if the absolute value of r is greater than 1, then we can see that this term goes to infinity as n approaches infinity, and therefore the series diverges. And if r is equal to 1, then we get a divide by 0 and the series diverges. Let's find the sum of the following infinite series, or state if it diverges. Well, we can see that the ratio between each successive term is constant and equal to a third. So therefore this is a geometric series. And if this series converges, then the sum is the coefficient a over 1 minus the ratio. So to write this expression in the form of the sum of the geometric series, we're going to assume a is equal to the first term, and then write the subsequent terms as multiples of a half. So what we get is 1 half plus 1 half by 1 on 3, and so on. And if we're writing this as a sum from n equals 0 to infinity, we have a multiplied by the ratio to the power of n. And the series converges because the absolute value of the ratio is less than 1. And therefore the sum of the series is the coefficient over 1 minus the ratio. And you can simplify this as 1 half over 2 thirds or 3 quarters.